What are nuclear fusion and fission? Both release lots of energy, but fusion releases more energy than fission. Both are also difficult to pull off. We can do fission, but not fusion. So fusion is our current goal. There are a lot of different forces involved, like the nuclear strong force and the electromagnetic forces. So let's take a closer look. Nuclear fission splits one particle into two. This happens when a particle hits uranium or another big atom and it splits into two different atoms, which releases lots of energy. We use fission to make energy, weapons, and nuclear fission? No. So what about fusion? Nuclear fusion compresses two particles together. Like what almost happened to Boo in Monsters, Inc. In the center of the sun, hydrogen atoms are crushed and turned into helium by using force, heat, and time. In conclusion, fusion is harder, cleaner, and produces more energy. Fusion compresses, and fission splits.
What does all of this mean? We've talked about how fission is the dividing of a larger nucleus into smaller nuclei, and how fusion is the uniting of smaller nuclei to form larger nucleus, as well as the implications these scientific principles have in our lives as we try to divide ourselves or to make an effort to unite with other people. Now that we've talked about all these things, what do we do next? The trick is taking a closer look at these unexpected connections and using them. Fusion is a lot better than fission. There are a couple of reasons for this, one being that fusion creates a lot more energy than a fission reaction. Light nuclei undergo a larger energy change when coming together than a heavy nucleus does when breaking apart. Secondly, the product of fission reactions is large amounts of nuclear waste. On the other hand, the most common product of fusion reactions is helium. Both reactions are looking for stability, which is the driving force of a nuclear reaction, and you could say is the driving force why people do what they do. Fission is very similar to how a person reacts when they are under a lot of stress. In an attempt to do everything they need to do all by themselves, they divide themselves up. Yes, perhaps it creates more stability and energy, but at what cost? Let's look at fusion on a personal level. Some smaller people unite together and what happens? The union produces large amounts of energy, more than each individual could have produced all alone. The problem is, fusion is hard. In fact, while controlled fission is a reality today, controlled fusion is currently a hope for the future. In order for fusion to become a reality, we need to create an environment in which a controlled fusion reaction can occur, which requires the particles in question to move at incredible speeds, resulting in extremely high temperatures. And we need to overcome the Coulomb repulsion, which is the name for the natural repulsion of like positive charges. In order to unite as a people, we will have to overcome the natural repulsion we have towards joining together and create an environment which allows that unity to occur. How in the world could that possibly work? Well, to start, we hope. Hope drives scientists to search for a way to create a controlled fusion reaction, and it drives saints to unite together in Christ. It takes reaching beyond what you can see to get somewhere you've never been. Then, as unexpected as it may seem, things start to connect.